Okay, good afternoon, students.
Good afternoon, madam.
Good afternoon, madam.
Good afternoon, ma'am.
Good afternoon, madam.
All of you, mute your cell phones. Okay, yesterday we have seen the introduction of the two blocks. That is a block.
Hello,
one.
ma'am.
Yeah. Don't disturb the class. Please mute your cell phones. Okay. So yesterday we have come. Mute yourselves. So if I mute them also, it is going unmute. It is becoming. That's why it is not possible. Okay. So yesterday we have seen the introduction of two blocks, block 1 and block 2 we have completed. So now we'll see the third block. So third block, it is about the Taylor's polynomial. And also we have the McLaren series is there in this. So block 3 is about Taylor polynomial indeterminate form, limits, evaluation and approximation is there. Okay. So if you have textbook, so try to open that and see the block 3. So in this, in block 3, unit 7, you have first unit 7 is about the Taylor's theorem is there. Taylor's theorem with Lagrange's and Cauchy's forms of remainder. Okay. So in some, whatever the section A is there, in that 5 marks question you may get for the Taylor's polynomial, and he will ask to find the what is the Lagrange's remainder or Cauchy remainder. Okay. So you will get these two remainders from the Taylor's polynomial. Theorem is there. So theorem also, yesterday we have seen the 6th unit. You have the 3 theorems. That is the Rolle's mean value theorem, Lagrange's mean value theorem, and also Cauchy mean value theorem. So from those mean value theorems only, you will get the Taylor's polynomial also. So Taylor's polynomial theorem. So theorem they may not ask, but whatever the problems are there, so you will get those problems. So if you see the unit 7, Taylor's polynomial is there, or you can call it as Taylor's theorem. So just you see how you can write the Taylor's theorem. That is f of b equals to f of a plus b minus a by 1 factorial into f dash of a plus b minus a to the power of 2 by 2 factorial f double dash of a. You can do continuation of this, that is cube by 3 factorial to the power of 4 by 4 factor. Like this you can go on, right? And at last we'll get b to the b minus a to the power of n by n minus 1 factorial f to the power of n minus 1 into a plus rl. Okay. So in the unit 7 itself, it is mentioned that to find the Lagrange's form of remainder and also Cauchy's form of the remainder. Here, whatever the Rn is there, Rn it represents the remainder. Okay. So this Rn value will be written as like this: b minus a to the power of p, b minus c to the power of n minus p, f to the power of n of c by p into n minus 1 factorial. Okay, if you remember this, from this, if you substitute the p value, wherever p is there, if you substitute that value as n, you will get the Lagrange's form of remainder. And if you substitute the p value as 1, you will get the Cauchy's form of the remainder. Okay, so you may get the objective type of question, or else problem will be also given. One of the function will be given. From that function, you have to find, you have to expand it in the form of Taylor's theorem. Then you have to find the Lagrange's remainder and also Cauchy's remainder. Okay. So here main important is if you know the Rn value. Even this Rn is called as Smomild-Roch remainder. Okay. Skomilchi-Roch form of remainder. Okay. This is one of the form of remainder. So from this, in whatever this Rn is there, if you substitute P as N, so here this is what it will become. Rn is equals to B minus A to the power of N. Ikkada enti B minus C, N minus N. N minus N means it is 0 and anything to the power of 0 means it is 1. So this value is 1. So no need of writing this one. This is Fn of C by, this is NO, N into N minus 1 factorial. Okay. So that you can write N into N minus 1 factorial means it is N factorial. Okay. So this is Lagrange's form of remainder. Okay. So now if you substitute P value as 1 in this, you will get as Rn is equals to B minus A to the power of 1 it is. And here B minus C to the power of 1 minus P value 1. No? So N minus 1 and Fn of C by P value is 1. So N minus 1 factorial. This is Cauchy's form of remainder. Okay. So these two formulas, if you remember, so any problem is given in that, first expand it in the Taylor's theorem. After that, substitute the values. Then you will get the answer. So this you may have the chance of getting further the 5 marks question. So in this, one more thing important one is from the Taylor's theorem only, McLaren series will be it is derived from the Taylor's theorem. So McLaren series is the important one. So sometimes you may get the 10 marks question or else 5 marks question you will get. So McLaren series derivation you have in your textbook. So McLaren's theorem you can tell or McLaren series, anything is same one. Okay, it will be in the form of this. If you remember the formula, so you can do the expansion of, in your textbook it is given expansion of sin x or cos x or log x or e to the power of x or a to the power of x or log of 1 plus sin x or sin into theta plus pi by 4, like this different type of functions are there. Those expansions, any one you will get for the 5 marks question. Okay. McLaren series will be in the form of f of x equals to f of 0 plus x by 1 factorial into f 0 x square by 2 factorial f double dash of 0, so on up till x to the power of n by n factorial fn of 0. So if you remember this formula, it's enough for you. On this you may get the problems or any expansions. Okay, this is about the McLaren series. So these two topics are there in the 7th unit. So you have the chance of getting only the 5 marks question, or else expansion of some functions are there. Whatever I have told now, trigonometric function or logarithmic function or exponential function, any one you may get for the even 10 marks. Okay. So this is about unit 7. If we'll go to the 8th unit is a very important one. So in this, both you may get the 5 marks question and also 8 marks questions. 2 questions you will get. And that is already while telling introduction, that is unit 1, I have told when you substitute the limit value, you will get the undetermined forms, that is 0 by 0 or infinity by infinity or 0 minus infinity, like that. Okay. So whatever the indeterminate forms or undefined forms are there, for those forms, we will use one procedure is with the help of the limit, that is RHL and LHL, you can find the limit value. So some problems will be there, whichever we can't find with the help of the limit, you have one more rule has been introduced. That rule is called as L'Hospital rule. So with the help of that L'Hospital rule, we can solve the indeterminate form functions. Whatever the limit value you are getting indeterminate, those can be solved with the help of the L'Hospital rule. So here L'Hospital rule is nothing but whenever and compulsory the given functions will be in the form of the fractional, that is a numerator will be there and the denominator will be there. Okay, single function, almost they will not ask. Oh, compulsory, it will be in the form, that is numerator, one function will be there, denominator, another function will be there. Okay, so whenever it is in the form of a fraction, you will get it in the form of 0 by 0, infinity by infinity. So when it is in that form, we apply the L'Hospital rule. L'Hospital rule says that we have to do the differentiation of numerator separately and also denominator separately. So first, numerator separately, you do the differentiation, denominator separate, and again substitute the limit value. If you get again indeterminate form, that is again 0 by 0 form or infinity by infinity form, again apply the L'Hospital rule and again substitute the limit value. If you get again same, then one more time, means you have to repeat the application of the L'Hospital rule up to wherever you get the answer as a defined one. That is some finite number. If you will get the answer, then you can stop the process, and that is the solution of the given problem. Okay, this whatever it is the procedure on this theorem also you have in your textbook, means state and prove the L'Hospital rule. They will ask in the examination that you might be getting for that is a 10 marks question, and it is 11th A question. Okay, even I am telling which question you are getting and how many marks also. Okay, so 11th A question it will come, and it will be for 10 marks question. If they ask the state and prove, if only small problem is given, means which is the just a quantity of only 4-5 lines, means then it will be asked for 5 marks question. And some problems will be there which we can't do directly, means we can't apply directly L'Hospital rule. Then you have to apply the log on both sides. When you apply log, whenever they will be in the form of like this, yesterday we have seen, if it is in the form of u to the power of v, and u and v are both the functions, then we apply the log on both sides and you make it in the simple form, and then we will do the differentiation. Okay, here also two types of functions will be there. One will be the simple one, which you can directly do the apply the L'Hospital rule. So if you are unable to apply direct L'Hospital rule, we'll go to the logarithmic functions. That is, we apply the log and make it into simple form, and then we do the L'Hospital rule procedure. Okay, so first unit 8 is about indeterminate forms. And the application of L'Hospital rule. Okay, this is the important unit. So in this, the main thing he will ask in the examination, what are the indeterminate forms? Okay, if you remember that one, compulsory 1 mark you will get there. So this, the indeterminate forms are infinity by infinity, 0 by 0, and 0 into infinity, infinity minus infinity, 0 to the power of 0, 1 to the power of infinity, and infinity to the power of 0. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, 3, 3, 6, 7 are there. So these 7, whatever the forms are there, if you remember them, you will get one compulsory objective question, that is multiple choice they will give. Okay, so this is about 1 mark, and about 5 marks is simple one problem will be given. So one example I will give like this: limit x tends to 0, 1 minus cos x by x square. Okay, so you can see that limit x tends to 0, 1 minus cos x by x square is there. First you apply the limit. What is the limit value? It is 0. So when you substitute here 0, 1 minus cos 0, that is limit. You are applying limit, so don't write limit. 1 minus cos 0 by 0 square means 0. Cos 0 value is 1. So it is 1 minus 1 by 0. It is in the form of 0 by 0. So you have got the answer in indeterminate form. Next step is what? You have to apply L'Hospital rule. In shortcut, I am writing apply L'Hospital rule. Okay, when you apply the L'Hospital rule, what it means that limit x tends to 0, do the differentiation separately for numerator and separately for denominator. Means don't think that it is in the form of u by v rule. Okay, u by v rule is there no in differentiation. Don't do that one. Do separate numerator and denominator. So differentiation of any constant number is 0, and differentiation of cos x is minus sin x. So it is, so minus into minus is plus. So sin x by x square is 2x. Okay. So now again substitute limit value as 0. Then it is sine 0 by 2 into 0. So 0. Sine 0 value is 0. So again it is in the form of 0 by 0 form. So again apply same L'Hospital rule. So when you apply, what it will become? It is limit x tends to 0. Sin x differentiation is cos x. By in the denominator, 2 is the constant. X differentiation is 1. So by 2. Now you apply the limit again. Cos 0 by 2. So cos 0 value is 1, 1 by 2. So we got the answer here. We didn't got any indeterminate form here. So such type of problems will be asked for 5 marks question. So here this is 5 marks and this is 1. So 6 marks you got from this unit, and you have the chance of getting even the state and proof of L'Hospital rule also. Okay. So if you have textbook, once see there some problems are there, whichever directly L'Hospital rule will be not applicable, then you have to take log on both sides and you have to solve. So such type of problems also you will get for 10 marks questions. You will see the 8th unit. So page number 186. It is 8.3.17 problem, or 185 page number 8.3.15, 8.3.13 problems. Such problems they will be asked for 10 marks, not for the 5 marks. Okay, why? Because taking log on both sides and making it into simple form, then applying the L'Hospital rule is possible. So such type of lengthy problems they will ask for 10 marks question. So this is about the 8th unit. And next one, if you'll see the 9th unit. 9th unit is about the applications of differentiation 1. So you have after this 10th unit, it is application of differentiation part 2. This is the part 1. So in this application of differentiation part 1, you have whether the given function, show that whether the given function is increasing function or decreasing function, they will ask in the examination. So this might be either 5 marks question or you may get for 10 marks question. Okay. So decreasing or increasing function. So first thing, any function will be given in the problem like this: f of x equals to x square plus 4x plus 2. So first thing is you take it as equation 1. Now you can write differentiate 1 with respect to x on both sides. So you'll get it as f dash of x equals to 2x plus 4. Constant 2 is 0. Okay. Now to see whether the given function is increasing or decreasing, you take f dash of x equals to 0. So our value is this one, that is 2x plus 4 equals to 0, implies x equals to minus 2 you'll get. So this, whatever the point is there, this point is called as stationary point or else critical point. Okay. So or we can in our polynomials or algebraic expression, we call it as a root of the given algebraic expression. It is in the form of ax square plus bx plus c. No. So whatever the x value is there, if you substitute there, what will happen? That whatever the function is there, that will become 0. That means at x equals to minus 2, the function is satisfying. So that's why this is called as a stationary point or critical point. So what will happen means, whatever the x value is there, if you substitute that value in f of x, so f of x means f of minus 2, it is equals to minus 2 whole square plus 4 into minus 2 plus 2. So it is 4 minus 8 plus 2. So you will get minus 2, which is less than 0. So whenever it is less than 0, it is called as decreasing function. Whenever you got the value as it is, you got a positive value and it is greater than 0, then the function is called as a increasing function. So you might get the problem like this only for 5 marks, that it may be 8th question or 7th question you may get. Okay. So one concept is about the increasing function and decreasing function. After this, the important one in this unit, 9th unit, is tangents and normal. Okay. These two is the 7th question, and compulsory you will get the 5 marks question on this one. Unit 9. So the concept of tangent and also normal. Okay. So in tangents, we'll have both tangent and subtangent. And here normal, also normal and subnormal. And one thing is the question will be for the tangent, equation of tangent for 5 marks. And here equation of normal. Okay. So if you remember the coordinate system in 9th class, you have coordinate system is there. What is slope? What is the equation of the any function? If one point is there, what is x1, y1? If 2 points are there, what is the equation? So you have those formulas. No, same similar concept here also applicable. So slope will be there if they are parallel, means m1 and m2 will be equal. If the two lines are perpendicular, then the slopes will be in the form of -1 by m slope. Okay, same similar concept here also it is applicable for tangent and normal. Okay, so equation of tangent means any equation will be given. To that you have to do the differentiation. You will get the dy by dx. So we can take like this example. It is y equals to x square minus 4x plus 2 is there. Okay, and here one point also will be given, that is 4, 2. Okay, so this point is x0, y0. And this is the equation. First thing is, first differentiate this one. Differentiate with respect to x on both sides. Okay. So dy by dx is equals to x square is 2x minus 4. This is 0. Okay. So we got this one. So this even it is called as f dash of x0. Okay. So this is called as a slope. So f dash of x0 is equals to dy by dx equals to 2x minus 4. Here the point is given now. So here you mention 4, 2. So that means this is the x value and this is the y value here. So it is 2 into 4 minus 4. So 4 to the 8. 8 minus 4 means it is 4. Okay. So now you got the slope value and you know the 2 points are given, x1 and y1. So the formula will be like this, y minus y1. If you take here x1, y1. Okay. So y minus y1 equals to f dash of x0 into x minus x1. This is the equation of tangent. So you should remember the formula here. So equation of tangent is y minus y1 equals to f dash of x0 by x minus x1. So here y minus y1, what is our y1 value? 2. That is y minus 2 is equals to what we got, f dash of x0 value 4. So 4 into x minus 4. Okay. So y minus 2 is equals to 4x minus 4. 4 is 16. So y equals to 4x. If you take 2 that side, you will get minus 40. So this is the equation of the tangent. So like this, the procedure is first thing you do the differentiation of the given function. After that, substitute the point. So point will be given in the question. You substitute the point and then you equate, substitute in the formula. If you simplify, then you will get the answer that is called as the equation of the tangent. So in this only I have told this is for 5 marks. They will ask, or else equation of the normal will be there. Just a slight difference will be there for the normal. Instead of f dash of x0, it will be minus 1 by f dash of x0. That is negative. I have told m is the slope and here minus 1 by m. So similarly minus 1 by f dash of x0 you will get. So if you'll see for this problem only, it is y minus 2 is equals to minus 1 by 4. It is x minus 4. If you simplify, cross multiply this, 4 into y minus 4 to the 8 equals to minus x plus 4. Okay. So if you simplify this, what you'll get? Minus x. So you need y, no? So 4y is equals to minus x plus 4 plus 8. So minus x plus 12. So we need 4y. So y is equals to minus 1 by 4x plus 4 by 3 means this you will get minus 1 by 4x plus 3. Okay. So like this, we can find the equation of normal and also equation of tangent. So these two questions, any one you will get for the 5 marks. So that will be the 7th question in section A. So after this, you next we have the length of the tangent is there, length of subtangent, length of normal and also length of subnormal. These topics are very important. The formulas for these four you might be getting in the objective type, and also problems will be asked in this one. So there is a 5+1 5 marks question and also one objective type. So they may be asked for multiple choice, or else in the math the following also they will ask, even the chance is there for fill in the blanks also. Okay. So length of tangent. So length of the tangent is y0 by y1 under root of 1 plus y1 square. Okay. So here y0 is the, in the question they will give the point, that is the y0, and y1 is the differentiation, first order differentiation. So in the second unit 2, I have told how the forms of the differentiation will be there. They will be in the form of dy by dx or y dash, or like this y1, or it will be in the form of f dash of x. So this is the form of differentiation. This is the point. Okay. Now next, length of subtangent. So length of subtangent is y0 by y1. Okay. This is, you have to remember these formulas. So if you remember this, you can do the problems, and also you can that is do the objective type also. This is the length of tangent and length of subtangent. So if you go for the normal and subnormal, length of normal, in the denominator it will be not there, just y0 into under root of 1 plus y dash square. Okay. So this is for normal, and next subnormal means instead of fraction, it will be multiplication, y0 into y1. Okay. So these are the 4 important things in the 9th unit. So 6 marks easily you can score if you know these concepts. So next we'll go to the unit 10. So unit 10 is about application of differentiation 2. Okay, 7th unit we have seen the application of differentiation 1. No, this is about 10th unit is in the block 4. Okay, block 4 is extrema, curvature, asymptotes, and curve tracing. So these, whatever the block 4 is there in that 11th and 12th unit, are from almost they are of the graphs. Okay, curve tracing is about the drawing of the sine theta or cos theta or logarithmic functions or any different functions, how to draw the graph. It is almost they will be explained in the even practical classes also. Okay, so 10th and 11th unit, in 10th unit you will get one 10 marks question, that is any function will be given. We will ask to find the local maximum or local minimum. Instead of local, it may be asked relative maximum, relative minimum, or global maximum and global minimum. Okay, these are all different names are there, but the concept of finding the value is the same one. Okay, so in 10th unit application of differentiation 2, maxima and minima and also curvature is there, but 10 marks question is about maximum and minimum. Okay, so in this, if you see 10th unit in your test book, 2 different types of tests are there. With the help of those tests, you have to see whether the given function is having the local local maximum value or local minimum value. Okay, so first thing is first derivative test is there. First derivative test is means if f of x, any one function will be given, to that you have to do the differentiation, that will be f dash of x. So for some conditions of f dash of x, it may be relative minimum and also it may be relative maximum. Okay, so that condition it is given as first derivative test. So but for solving the problems, it will be easy if you use the second derivative test. Okay, so first derivative test, after finding the critical value or stationary value, that value is called as f of, that is x naught value. So if f dash of x naught greater than 0 and okay, this is only f of x and this is x naught less than 0. If you got like this, f dash of x greater than 0, and after substituting the critical value, if it is less than 0, then we call it as relative maximum. Okay, and in the similar way, if f dash of x is less than 0 and f dash of x naught is greater than 0, it is relative minimum. Okay, so this test, whatever the sentences are there, it is in your textbook. And if f of x naught is neither relative maximum nor relative minimum if dash of x does not change sign, means it is constant only. It is not less than 0, it is not greater than 0, then we'll tell that whatever the function is there, it has neither maximum value nor minimum value. Okay, these three are conditions are there. And for solving the problems, you remember the second derivative test. It will be useful, means it will be somewhat easy compared to the first derivative test. So second derivative test is, that means after the f of x, you have to find first order. So you will get f dash of x. Next, if you do one more time differentiation, you will get the second order differentiation. That will be f double dash of x. So the condition is, if you remember these 2 points, it's enough for solving the problems. F dash of x naught value is 0 and f double dash of x naught is less than 0. Then f of x naught is relative maximum. Okay. Here you may get relative or global. In some questions, they will ask global also. In some, they will ask local also. So these three are same only. Relative maximum or global maximum or local maximum. Second one is, if f dash of x naught is 0 and f double dash of x naught value is greater than 0, then f of x naught is relative minimum value. So reverse is there, see, greater than. That means for second order differentiation, if you'll get the positive value, we call it as a relative minimum value. If second order differentiation, you got the negative value, we call it as a relative maximum value. Okay, if you remember these 2 points, you can solve the 10 marks question. Okay, so this is important in unit 10. So only this topic is there in unit 10. Next we have unit 11. It is about the singular points and asymptotes. So this, all the definitions are there. In this, many concepts will be there. So all definitions and what are the asymptotes and what are the singular points, you can learn in them. So it is there in almost in practical textbook. At the time of practical classes, you can learn those topics. So unit 11, only 5 marks question will be there. You will not get the 10 marks question. Next, unit 12 is the important one. So unit 10 and 12 are the 10 marks questions. Okay. Unit 12 is curve tracing. In this, sin x, cos x, x square, x cube, and a circle is there, no, x square plus y square equals to r square. That type of questions. They will be asking to draw the diagrams, okay, to trace the curve. So those questions you will be, means they will be given as A and B. 5 marks will be given for each question, because lengthy 10 marks questions are not there. Okay. So 5 questions it will be shared. In this, only one more topic is there. Polar coordinates is there. So that polar coordinates also you will get 5 marks question. Okay. So this is about 11th and 12th units. So if you are perfect with whatever the units I have told in all the blocks, you can score good marks. Okay. Now this is the introduction about the 4 blocks. And I already have told what are the important questions and what are the important units. Okay. Try to practice those. If whatever the topics are not covered in our class, you can practice with the help of the introduction class also. Now we'll go to the first unit. It is about the limits is there. So limits and continuity. So at the time of the introduction, I have told what is the concept of the limit, why we are using the concept of limit, because such functions are there in which you will get the answer as the indeterminate form. Okay, to solve those such functions, we'll use the concept of the limit and we'll find the limit value. So even you have the definition in your textbook. So try to see the definition. In some cases, they will ask the definition of the limit also. So in page number 3, you have the definition, that is 1.2.1. So but remember this one, only these 2 points, epsilon greater than 0, delta greater than 0. Okay, unit 1, epsilon greater than 0, delta greater than 0. Here for S subset or equals to R, you have to remember these two, is less than delta and also mod of f of x minus L is less than epsilon, then we can write the limit as like this. If you remember these 3-4 points, you can easily write the definition of the limit. If these two conditions are satisfied, then we can write the limit in this form. So in this, f of x tends to L if x tends to A. If x tends to A, f of x tends to L, then the limit of any function will exist. Okay. So even from this only concept, from these two, you have no modulus. So if we'll take out the modulus of this one, 2 we can write. I have told the modulus is equals to minus x if x is less than 0 equals to x if x greater than. If you remember that concept from here, you will get minus x minus a less than delta, and here plus x minus a less than delta. If you simplify this, you will get it as a minus delta less than x less than a plus delta. That means x belongs to minus a minus delta, a plus delta. Similarly, for this also, if you will take out the modulus, that is f of x minus L less than epsilon minus f of x minus L less than epsilon, here f of x minus L less than epsilon. So if you simplify this, you will get it as f of x less than L plus epsilon, L minus epsilon. Okay. So this means f of x belongs to L minus epsilon comma L plus epsilon. So when you compare these two, and you have the diagram in your textbook, if you draw like this, and whatever these two values are there, if you draw in the number line, A is the midpoint of this one, and whatever the neighborhood is there, we can find the neighborhood of any point. Number line means it is a real line. Real numbers line will be there. No, in that real number line, all the natural numbers, whole numbers, integers, rational numbers, irrational numbers will be included. So the combination of these all numbers, it is called as a real numbers. So that's why we can mention any part of numbers in the real line. So in real line, if we'll take A as any number, so left hand side, whatever it is there, it is the A minus delta, and right hand side, it is the A plus delta. Okay. So this is called as a neighborhood. Okay. So neighborhood of A is A minus delta and A plus delta. Here we got x belongs to A minus delta comma A plus delta. So this point, if you take A, okay. So on its neighborhood, you have A minus delta, and on its here you have A plus delta. Okay. So if you take similarly for this, it is the f of x, it is equals to L, and this is x is equals to A. Okay. So here if we'll take L minus epsilon, and if we'll take here, it is L plus epsilon. Okay. If you draw any function like this, it is in the form of y equals to f of x. It is passing through the origin. This is the x-axis and this is the y-axis. So from here, these two are related to each other. Why? Because when x tends to A, f of x tends to L. Okay. So these are the f of x values and these are the x values. So A minus delta and epsilon minus delta both are here same. And here you'll get like this. So this graph you have in your textbook after the definition of the limit. Okay. So this graph, how you will get means when you compare when x tends to A, f of x tends to L, and you will get the midpoint here. In this case, if a function is like that, y equals to f of x, whatever the epsilon value and delta value, both are same here. Okay. So these two values, I have told already in the introduction that epsilon and delta are the positive arbitrary constants, and also they are the integers. They depend on each other. So if this is increased, that also increased. Okay. So both, if you have like this, the curve, it is in the form of y equals to f of x, then we'll say that epsilon and delta values are same. If y is equal to 2x, then epsilon value is equals to 2 delta. So if only y is equals to x is any function, then epsilon value equals to delta. If y equals to 2x, then epsilon value equals to 2 delta. If y equals to x by 2, then epsilon value is equals to delta by 2. Okay. Like this, these all values depend on epsilon and delta. And yesterday we have seen that is limit extends to 0, x square minus 1 by x minus 1. Whatever the function is there from right hand side and left hand side, we have seen the values. They are approaching to x equals to 1, and also they are approaching to f of x equals to 2 values. So they depend on epsilon and delta values. Okay. So this is the main concept of the limit. Okay. But this, whatever the concept is there, it is only for the definition. But solving the problems, we need another concept, that is finding the RHL and also LHL. Okay. So these, if you remember these all, it will be useful for the solving the problems. So before going to the problem on limits, some important points are there. That is, you have standard limits are there. So from these standard limits, one compulsory you will get for the objective type of question. And also these standard limits means the value will not change. Anywhere if you get the question in that form, directly you can apply the standard limit and you can directly write the answer there. Okay. So try to write these all standard limits. These are useful for objective type and solving the problems. Standard limits. So first one is limit extends to 0, sin x by x equals to 1. Even this is equals to limit extends to 0, x by sin x also. Okay. If reverse is also there, then also that value is 1 only. Okay. So in some problems, if you see, if like this also given x tends to 0, sin 2x by x is there. Then to make this value as 1, here multiply with 2 and divide with 2. Okay. So multiply with 2 and divide here. 2 will get cancelled. It will be in the same form. Then you will get the answer as 2 here. Okay. So why? Because this value is 1. 1 into 2 is 2. Okay. So like that also question will be given. So these all are for the objective type. So next, second one, limit extends to x to the power of n is equals to a to the power of n, a greater than 0 for all x belongs to R. Next, limit extends to a, x to the power of n, a to the power of n by x minus a equals to n into a to the power of n minus 1. Limit e to the power of 1 by x equals to 0. Okay, this is the important one. And this is the important one. So these you will get in the objective type. Next, e to the power of x by x equals to 1. Sixth one, one by x equals to e. And seventh one, limit x tends to infinity, e to the power of x equals to infinity. So these all are objective type questions. Whatever I am keeping the star mark, those are useful for objective type and also for solving the problems. Directly you can write the answer there. Next, eighth one is and this is a very important one. Okay, 10th one. So these all are the standard limits, means the value will not change. Standard in the sense, wherever the problem, if you're getting in this type, there directly whatever the answer is there, that answer you can substitute that. So these are about the standard limits. After this, you have the properties of the limits. So if you know the properties of the limits, you can solve the any limit problem. Properties of limits. First one is So first one is if limit extends to a, if you have constant and also another function. Okay, C represents the constant and one more function is there, means we can write it as, we can separate the constant outside and the limit extends to a f of x. So you can take the example, if 2x is there, limit extends to a, then you can write 2 outside and limit extends to a x. Okay, like this. This is the concept of this first property. Next, if we have the addition or subtraction of two functions, f plus or minus g into x, so it is equals to limit extends to a f of x plus or minus limit g of x. You can take f as sin x and g as if it is exponential function or logarithmic function. Then you can separate and you can do the limit. And third one, limit, have the multiplication of the two functions into limit extends to a g of x. And fourth one is division. You will have let limit extends to a f by g of x. So limit extends to a f of x by limit extends to a g of x. Okay, so these are the properties of the limits. These will be useful for solving the problems. Okay, so next we'll go to the problem on limits. So first one is show that the limit extends to 0 mod x by x does not exist. In the problem itself, it is given that limit does not exist, means RHL and LHL value both are not equal. So question is show that limit extends to 0 mod x by x show that limit extends to 0 mod x by x does not exist. Okay, so this is the question. So for this, the solution is, first thing, already we have known the what is the modulus concept is there. Modulus of x is equals to minus x if x is less than 0, and it is equals to positive x if it is greater than 0. Directly that concept you can apply and you can solve this problem, or else which two methods are there. So we'll see the first, finding the RHL. So RHL is equals to limit extends to 0 plus mod x by x. Okay, so directly you can do like this. Mention here in the brackets, it is that is mod x is equals to x if x is greater than 0. So in place of mod x, you can write limit extends to 0 x by x. So xx will get cancelled. It is limit extends to 0. So constant limit is the same one. Okay, this is one procedure. So another one is we can convert it into H form. That is, after writing this, you write h tends to 0, h greater than 0. In place of x, substitute 0 plus h by 0 plus h. So you'll get it as limit h tends to 0, h greater than 0. 0 plus h is mod h. And when x is greater than 0, positive you'll get. So this is h. So it is limit h tends to 0 of 1 is 1. Okay, we're not able to see. It is equals to limit h tends to 0 of 1 is equals to 1. So this is one method and this is one method. Okay, so direct modulus in some cases we will not use. Why? Because in some you may have the numbers like this 2 plus x or 5 minus x modulus. Okay, so in such cases it will be difficult to use this concept. So that's why if you write in place of x 0 plus h, then it will be easy for us to solve such problems. Okay, so this is RHL we got. Next, if we see the LHL, it is equals to limit x tends to 0 minus mod x by x. From this concept, we have limit x tends to 0 minus mod x will become minus x by x. So it will be limit x tends to 0 minus minus 1 equals to minus 1. So minus 1. So like this, you can mention here mod x is equals to minus x if x less than 0. Okay, you write that. If x is less than 0. Okay. So compulsory mention those in the bracket. Then you easily it will be understood that what concept you are using here. So next, the second method is limit x tends to 0 minus. In place of mod x, you write 0 minus h by 0 minus h. Okay. So it is equals to limit h tends to 0, h greater than 0. So limit h tends to 0, h greater than 0. So this is modulus of minus h by in the denominator minus h. So modulus of any negative value, it will become the positive value. So here you will write limit h tends to 0, h greater than 0, minus h will become h, and the denominator negative is there. See here in the numerator, we got negative value. When you'll do here, you got the denominator. Okay. So if you cancel out this, you'll get limit h tends to 0 minus 1 equals to minus 1. So LHL value we got as a minus 1. Both we got different values. So after finding like this, here we write, therefore RHL is equals to 1 is not equals to minus 1 equals to LHL. Okay, both the values are different. So here you write, so RHL and LHL exist, but they are not equal. They exist means they got some value. Instead of getting the indeterminate form or undefined form, they got some value. Therefore, both the values will exist, but they are not equal. So therefore, limit does not exist. Okay. So like this, you have to do the problem. So try to write all the steps. Then only you will get the full marks in the examination. So this is about the first problem. So this is you'll get for the 5 marks question. That is the first question in the section A. Okay, next we'll see one more question in the limit only. So this concept is a very important one. That is limit x tends to 0, e to the power of 1 by x minus 1 by e to the power of 1 by x plus 1. Okay, just now in the standard limits, I have told this concept. So when to use e power 1 by x as 0 and when to use e power 1 by x as, that is for negative and positive values, when you'll get the value as 0. So for this, in the solution, you write when x tends to 0 plus, that means when x is of 0 a positive value, then a 1 by x tends to plus infinity and e to the power of minus 1 by x tends to 0. See here, when x tends to positive values of 0, 1 by x tends to infinity and e to the power of minus 1 by x will tend to 0. That means wherever here in the question e to the power of minus 1 by x is there, there you can write directly 0. Okay. But in the question, if you see e to the power of 1 by x is there. So while finding the RHL value, we have to convert the e to the power of 1 by x as minus 1 by x. Okay. And next one is when x tends to 0 minus 1 by x tends to minus infinity and e to the power of 1 by x tends to 0. So for LHL, no need of taking the separate and converting it into minus 1 by x. Why? Because when it is the negative of 0, the value of e to the power of 1 by x will tend to 0. That means directly you can substitute here 0 minus 1 by 0 plus 1. Okay. For RHL only, you have to convert this one. So for finding the RHL, it is equals to limit x tends to 0 plus e to the power of 1 by x minus 1 by e to the power of 1 by x plus 1. So, okay. Now to convert this one, you take e to the power of 1 by x common in the numerator and denominator. So 1 minus 1 by e to the power of x by, here also 1 by x, 1 plus 1 by e to the power of 1 by x. If you cancel out these two, then what will be remaining? So 1 minus 1 by x, that is limit x tends to 0 plus 1 minus e to the power, if you'll take it in the numerator, minus 1 by x. So 1 plus e to the power of minus 1 by x. Okay. So this, now you apply the limit here. What is there? Whenever it is a 0 plus 1 by x tends to infinity and e to the power of minus 1 by x 0. So here it is 1 minus 0 by 1 plus 0. So you'll get the value as 1. Okay. So this is about RHL. So when you'll find the LHL, so LHL is equals to limit x tends to 0 minus, directly here we have to apply the limit e to the power of 1 by x plus 1. That is e to the power of 1 by x value is 0, 0 minus 1, 0 plus 1. It is equals to minus 1. Both are different values. So therefore, RHL is equals to 1 is not equals to minus 1 is equals to LHL. Okay. So now same you write both RHL and LHL limit exist, but they are not equal. Therefore, limit does not exist. So like this, by the stepwise, you have to solve the problems. So this is the concept about limit. Next, we have the concept of continuity is there. So continuity definition, we have seen in the introduction. So any function is said to be a continuous function if first thing is limit should exist. If limit exists and that limit value is equals to f of a, then that function is called as a continuous function. So first one is limit x tends to a, f of x should exist and the value should be any finite value. Okay, it should not be any indeterminate form or undefined form. Second one is this limit x tends to a, f of x should be equal to f of a. If these two conditions are satisfied, then the function is called as a continuous function. And you remember that as far as the graph, if you draw any diagram like this without lifting the pen, it is y equals to x square function. So if you from starting point to ending point, if you are taking the pen without lifting, so such type of functions are called as a continuous function. And if you see like this, any gaps are there in between. Okay, and you are lifting the pen, such type of functions are called as discontinuous functions. Okay, so what are the examples of continuous and discontinuous function also you might be getting in the question. And here in the test book, it is given the what are the properties of the continuous functions. So this is the very important one. If you know the concept of this one, you can solve other unit problems also. And also it is a objective type question also. So what are the properties of continuous functions? So here 5 different type of functions are there. They are always continuous. Means no need of finding the proof that one. Already they have proved that these functions are continuous in their domains. Okay, in their domains means they will have some values. If you see the sin x, you will have -1 and 1. So like the different, they will have the domains. In the domains, these 5 types of functions are always continuous. Okay. So if you see anywhere those functions, directly you can say that those functions are continuous functions. So such type of functions are okay. First function is constant function f of x equals to c. This is the constant function. Okay, constant function is always continuous. Okay, next second one is f of x equals to x. This is the identity function. This whatever x you will put here, you will get the same one. 1 means 1, 2 means 2, 3 means 3, like that. So such type of function is called as identity function. Okay, it is also always continuous. And next third one is f of x equals to any trigonometric functions. That is sin x, cos x, tan x, so on. Whatever 6 trigonometric are there, those. And next fourth one is f of x equals to logarithmic functions. And fifth one is f of x equals to e to the power of x. And sixth one, any polynomial. Okay, these 6 type of functions are always continuous functions. Okay, and even when you'll go to the second unit differentiation, these 6 functions are always differentiable also. Okay, so if you remember this, you will get any objective type question on this. And you have seen the properties of limits, no? That is f plus r minus g. If two f comma g are continuous functions, okay, they should be continuous functions, then f plus r minus g is also continuous function. Okay, f by g also continuous function, and f into g is also continuous function. Means if two functions are, that means you can take any two functions from these 6. If two functions are continuous function, then addition or subtraction of those function is continuous function, or division or multiplication. Okay, so remember these points. With the help of this, you will get one objective type of question. So properties are there. After that, so we'll see in next class the problem on continuous function. Okay, students, if you have any doubt, you can ask in next class. So we problems are there or continuous function. Next we'll go to the second unit in the next class.